Hi everyone. Today we will talk about those things. I would like you to look at the software development, oil and gas industry, and failure predictions. Please, we have prepared a funny question to the audience. I would like you to raise your hand if you think that intelligent assistant is number one.
This is not school.
Okay. If you think that intelligent assistant is a software agent that can perform tasks and services, please raise your hand. Yeah. It's better. And for number 3? Cool. So we might start. Okay. No? We
No?
could not? Why? Sorry. My name is Andy. I work as a vice president at SoftElegance Data Company. We are dealing with industrial information, mostly from oil and gas industry. My colleague Yaroslav, he's the system architect of the software system that we are going to present. Shortly about the presentation structure. Now I will guide you about the oil and gas industry in general. Then we will talk about data lake that we are building. Data collection would be about Spark streaming, ZigBee, and other technical details. And the magical part is about data analytics and what we are exactly doing in our oil industry. So in general, oil industry is very huge, but everything is already automated, each of that processes with enterprise solutions, with software as a services, SaaS systems, with small custom applications. But everything that on there is generating data, and we are trying to get some value from that huge amount of data. We could gather actually terabytes or petabytes of information, just getting them from onshore platforms, offshore platforms, and so on. One rig during the production process could generate 100 terabytes of information, but it's during the production process would be much more. But the question is it would be like just numbers from that process. So for the companies right now, it's really important to monitor everything that is underwater. It's a big challenge, and companies see a lot of potential just getting some values from that underwater. The same, big companies, we've been talking with a lot of engineers from Houston, Norway, and so on. And big companies, they are building their own data lakes, which really closed. I mean, they're totally not public. And unification is the thing that we see that we are really far away from some big unification. It's mostly question and challenges about unification of data inside big companies. And obvious that predictive analytics is important for everyone, from all the industries, all the speakers we've been talking about predictions, and we of course too working to predict some things. Failure prediction. It's really important, you know, that intelligent assistants could generate real values if we can predict failure. Going forward, Yaroslav will tell you about how we're predicting failures of fraud pumps. and it's one use case. But in general, for oil industry in particular, it's also important. Talking to the point number 2, it's of course all the equipment is already automated in some way. So that standalone applications they do in digital management. But now we are talking about global models, about globalization, using industrial internet, using industry 4.0. We are going to create global models for type of equipments that are working all around the world. And the third is actually on the market there are no sustainable solutions for manage overhauls of wells. So Yaroslav, okay. Conclusion for my part that all oil companies already used Hadoop for their needs. Most of them started to use Spark, and all that we've been heard today about Spark family. Both type of companies already generated petabytes of information, and they are thinking about the values that could be generated from all that information. But the real thing that's not about petabytes. It's about value, and data analysts which can find some problems, and that problems Yaroslav would continue with them.
So let's deep dive more to technical question. Our data lake could be described just in 4 words: store, collect, analyze, and deliver. In details, we pour different type of information, structured and unstructured, to our lake and try to catch and cook fish. Our analytic block at this muddy water, and deliver it to end users with a different set of services like web, mobile, etc. For storing, sensor reading, and few other sources, we require it in distributed database with high availability and without a single point of failure. Our choice for this, Cassandra. For unstructured information like text, files, photo, etc., as we have no Hadoop legacy, we try GlusterFS. All okay with it, but we realize that with Gluster we lose in data locality. Majority part of incoming information should be converted into our internal format. Furthermore, part of it should be left as it is in plan use Parquet. Key point of our infrastructure doesn't matter whether we are talking continuous integration, Jenkins, or cluster manager methods. We're now in progress at migration of methods, is automation. And as a result, our system will look like a set of Ansible playbooks. Another key point of our infrastructure is that our data lake should be cloud agnostic. We try avoid any vendor lock. Now in our internal environment, we built custom private cloud, but system could be deployed at AWS, Azure, doesn't matter. Data collection. Since middle of 90s, implementation of Smart Well begins. Smart Well, what does it mean? This is complex of hardware, sensors, and software which monitor all urgent parameters of well and equipment embedded on it. Especially this is very helpful for places with difficult access like Arctic, jungle. Sensors could be embedded at already work at well without work process participation. Incoming information could be streamed at real time, and for handling this information flow we use Spark streaming. So our information collected and stored, let's get inside of it. Start from simple. Our analytic block consists from set of services which operate from different slices of information from our lake. Our teams likes to use different notebooks like Spark Notebook, Jupyter, less Zeppelin. All this notebook we use in our internal environment for prototyping and investigation, but one of it could be included at deployed configuration as additional service. At screen you could see example with simple queries at Spark Notebook which connected to our Spark cluster. Portion of information was loaded from Lake and simple analysis was implemented on it. At next slide, you could see our approach in last file analysis. Last file, this is commonly used in well and oil gas industry file format for well logging information. We developed our Python module for manipulation with it. At screen, you could see example how well parameters changing during drilling depending on depth. During conversation with domain knowledge specialists, we get insights that it would be very useful for industry build system which monitor health parameters and performance of oil facilities and working processes, especially occurring underground, and determine remaining useful life of all critical components and predict failure before they occur. In other words, prognostic health monitoring or predictive maintenance. It could be two different scenarios. First, when we try predict time left before failure, and second, when we try predict whether facilities are likely to fail or its nearest state. All these cases we unite in one service called Intelligent Assistant, which would be very helpful for engineers in their daily work. Prognostic health monitoring workflow. For each type of equipment and working process, we should create specific model, and at incoming information we should identify which model should be used for this case, apply it, and notify end users about result. Let's look at practical example with artificial lift system. This facility became a symbol of oil industry. Artificial lifting is used when well conditions are insufficient to lift reservoir fluid to the surface at required rate. Different type of lifting exist, but among the mostly used, we can name sucker rod pump, displayed screen, and electrical submersible pump. If you would visit Texas and drive your car from San Antonio to Houston, you could see a rod pump near the road endlessly working. Question: why is this equipment so interesting for us? There are more than 2 million of wells in operation worldwide. More than 1 million of wells use different type of lifting, and nearly 750,000 of wells use sucker rod pump. Interesting fact, that just 1% improvement in electrical submersible pump performance would provide additional 500,000 barrels of oil per day. We have target. Our main problem, rod pump failures approximately could lead to 2 weeks of downtime for oil producing. Our challenge: prevent reduced downtime, as a result reduce costs, especially would be very helpful handle pre-failure state to help support engineers team service rod pump. Our dream, we want to build global failure prediction model that could be scaled to all wells in each oil fields worldwide. But let's start from simple and deep dive to our machine learning workflow, which we developed to deal with such kind of task. First question, which ML task we should solve? Multi-class classification for dataset labeled with 3 different classes: normal, pre-failure, and failure. Our general ML workflow consists from 6 steps: data preparation, feature selection, labeling, training, evaluation, and prediction. Nothing new. The source of our data is pump of controllers, POC, which generate different parameters for sucky rod pump, like KERD area, minimum surface load, maximum surface load, etc. As you could understand, this set of measurements forms our feature which we would use for model training. Our incoming information very noisy and dirty. Equipment mistakes, empty data, outliers. At preparation step, we have to do data cleaning. For example, moving median, good techniques for noise reduction. For feature selection, very important is that found predictors should be able to capture different patterns which operators usually use to identify rod pump anomalies. Accordingly, labeling, our dataset contains just two classes, normal and failure. So our task extended with third classes pre-failure and filled empty value. After this step is finished, we would be able to move from semi-supervised learning to supervised learning. Training. We tried different algorithms like logistic regression, support vector machine, naive Bayes, decision trees. The best result was showed by logistic regression and support vector machine. We stopped at logistic regression. Our main two tools for ML, scikit-learn and Spark MLlib. Very important point for evaluation step. We should minimize false positive rate for prediction. Mistaking such result could lead to chaos that wrong decision to stop well, unplugged rod pump for investigation would be made. As a result, we would lose time and money for nothing. Before we deep dive in example with real-time prediction, I want to discuss with you problem related with technical debt. Yeah, looks like zoo with technology at screen. Now we use two libraries for ML. Of course, it would be better just have one silver bullet for all potential cases, or, for example, just rewrite all algorithm by yourself. We realize that this is very hard to do. If we will have just one model, it would not be a problem for us. But in real situation, we operate with different set of models or cases when we should train model in one language and tool and reuse in another language and tool. Of course, you could ask me that we live in microservices world. We could write service, wrap model, organize REST API, etc., etc., etc. All this work. But as for me, it looks like technical debt. Only two approaches, as I know, available to deal with such kind of task. First is predictive model markup language, PMML, and second, portable format for analytics, PFA. Last project, very young, but as for me, looks very interesting. Conclusion. We have no ideal solution to solve such kind of problems. We just only need to minimize technical debt. In our team, we're thinking about creation internal format for model sharing, but not just only thinking. Maybe at nearest future we will come back to this task. So, real-time prediction. For handling incoming information flow, we use Spark streaming. We load our trained model to broadcast variable, and then on client side, apply to incoming information, and based on received prediction, if we have failure or pre-failure state, store it at database and notify end user. Two parameters to keep in mind during Spark streaming: scheduling delay and processing time. Try to minimize scheduling delay, and processing time should be less than selected batch interval. So, what about end users?
Yeah, Yaroslav, this is actually the results of what we've been talking about. This is a screen. All that machine learning called data lakes, everything was about that yellow box, which predicts the state of rod pump. So it's actually, that's what we are proud about.
Yes, just 10 to 15 slides we could just show to the screen and this yellow box, and that's all. So let's make conclusion of our talks. First, digitalization, collection, intelligent analysis give us better insight. Approach in building such kind of system could be scaled not only for gas industry, but for medicine, smart city, and for industry 4.0 and industrial internet in general. And if you ask me question, is Spark a Swiss knife for our data lake? I would tell you yes. We use SQL, batch, MLlib, and streaming. This is reference for very interesting research related with sucker rod pump and electrical submersible pump. Example with using ZigBee for remote monitoring. You could review it. Very interesting. I recommend. And collect, analyze, insight. Thank you.
Yes, we have 9 minutes for questions.
So we're ready to handle all questions.
Please.
Hi, hello. I wanted to know, have you built a prototype of this system and with real data? And if you have, I'd be interested to know what you thought were the main challenges with building and analyzing the data.
With challenges with building such kind of system, yeah?
Yeah.
First challenge is cleaning data and identifying main problem, because a huge amount of communication with domain knowledge specialists, very hard to understand what exactly we should to do before we could start. So if we came back to our ML workflow, potential first 3 steps, data preparation, feature selection, and labeling will take much more time than last 3. This is main problem, to mix domain knowledge, engineers, data scientists, and get inside of it. Because in oil industry, the very big
challenges from my side is asking about real data. We have a data generator that we used previously. And the second challenge is we could not disclose the name of oil company we are working for with that, because, as I said, that they are really closed and not even name of the company, unfortunately. Yeah, please.
Is there any specific reason not for using?
No. Yeah.
So, is there any reason for not using? Okay. Thank you. So, is there any reason for not using, for instance, clustering for failure prediction?
Clustering prediction. This is just only one service. Clustering we using for just moving from any handwork with managing our cluster. I'm sorry, you're talking about clusterization with data analysis. Clustering. Okay, yes. For labeling we use clustering, probabilistic clustering, expectation maximization, as we have understanding exactly what are our data. So clustering could be used in such kind of case. And after clustering, we have 3 classes: normal, pre-failure, and failure. Because before clustering, our dataset labeled just only with 2 classes, normal and failure. Yes, of course.
So, you mentioned this real-time data. It's hard to get. And how do you validate these models?
Yeah. I will cover. Before we start, we realize that real data is very hard to get from oil company. So we have engineer with huge experience with oil and gas industry, and good engineer in general. And he wrote generator which emulate work of pump controllers, which I described previously. So we have soft implementation of pump of controller which installed at equipment and captures this data. So we have
so you mentioned there were two approaches to deal with technical debt. One was the portable format for analytics, for model sharing, and there was another one which I didn't catch. Could you re-explain what that one was?
back to predictive model markup language.
So you mentioned there were two approaches to deal with
PFA and PMML, yeah?
PFA and
PMML.
PMML. Okay, thank you.
Yes,
Come back to that slide. Here it is.
Yeah.
Yes, please.
Oh.
I'm quite interested in the first slide where you said there were challenges in unifying the data within the same enterprise. Were these mainly political problems, or was it a data domain knowledge problem or modeling problem?
No, it's because all that oil companies are not sharing data among others. So they are at the stages of like just starting to use Spark and so on. So like currently they are collecting data and that's all. So all of them collects. But next,
I will add that as Andy mentioned, this company very closed, and this is a real big problem in industry. I think this is not only in oil, but in automotive industry, medicine, company very close. Each company use specific format. Even understanding what does mean oil well in different component is different. So very hard. One big company called Schlumberger exactly at current time working at such kind of task.
yes, please.
Could you comment on how difficult it was to get the correct IMS keys and equipment tags and be able to connect to historians to get the data? Was this a manual process, or do you have any automated ways of doing this?
Your question was how it's hard to connect with specific sensor type of equipment, yeah?
To actually be able to map out which equipment tags you needed and which IMS keys you needed, and then how to connect to the historians to get to the data. Was this already all known in advance? I know this is an issue in general with these kind of systems.
Maybe for me it's hard to understand question.
So if you want to get access to sensor data,
yeah.
Yep. Then knowing which sensors, which equipment tags, which IMS keys, connecting to the historians to get that data, was that very easy, or was that a difficult process?
No, this would be understand. This would be additional step before integration our system with. We have 2 people who would work specific for covered question related with sensors, how this information would came into our information. As you know, different format like ZigBee, MQTT used in Modbus in oil and gas industry. Huge amount of this format, and our additional team will consist just from 2 people who will work at this topic.
But in general, it was not so hard because everything is specified and could collect at local rigs servers. So
just main problem to unify this lake to our internal format.
Yes, you please.
So one more question about PMML and the PFA format. So you just mentioned in your talk that PFA is beneficial. Can you maybe make some comments why you want to use PFA and not PMML?
Yes. As for me, when I was to look at PFA, it looked like just we'll have one predict function, and that's all. We export this predict function to JSON-like format and then reuse. So from point of using this, PMML for me look like more, not legacy, but more huge, more hard. PFA just one predict function and that's all. We call it and that's all.
Okay. And the last question, please.
Yeah, just looking at the slide, and you describe this as kind of a technical debt. Could you explain a little bit the concept behind this? Is the technical debt because it's a lot of many formats, or what was the reason?
Too many libraries for ML now present in our real world. So, as I mentioned, we have no ideal solution to build each different type of model and just use these tools in our usually daily work, because we come in with problems that we should found specialists for specific library, etc., big set of data scientists, and then we should decide how, when we train model in one tool, how we would use in another tool, etc., how we'll organize the communication. I have talked with engineer from Samsung team, and the same problem he mentioned inside Samsung R&D, and he also decided not only to think about creation internal format, but already start this work, and now this work in progress inside Samsung about some general format for using between. Very interesting document at morning speaking, CEO of Databricks underlines this problem with technical debt at ML, document from Google. I recommend to all of you read this paper, very interesting. Each type of problem which I mentioned this briefly described in detail in this document.
We'll come here because we're out of time. So thank you once again, everybody, for coming, and